Hi everybody. So today's lesson is about vectors and addition of vectors. So just to remind you what a vector is, vectors are physical quantities like displacement, velocity, acceleration that have got both size and direction. So there are some things we need to keep in mind when we add vectors. So here's an example. So Mrs. John walks 4 meters from A to B, and then she walks 4 kilometers, and then 3 kilometers from B to C. So the total distance that Mrs. John walks is 4 plus 3, which is 7 kilometers. However, the displacement for Mrs. John could be any number between 1 and 7 depending on the direction that she's walking in. So suppose she walks in the same direction from A to B and then from B to C. So the black arrow is a vector, 4 kilometer vector in the direction Mrs. John's walking, and then B to C is the other one. So when you add vectors, you add them head to tail, and the resultant vector goes from start to finish. So this red one is the resultant, the black is the first one, 4 kilometer vector, the blue is the 3 kilometer vector. So when you add them, you get 7 kilometers. Okay, so in this case, the distance and displacement are the same because there's no change in direction. However, if Mrs. John decides to turn around after walking 4 kilometers and goes in exactly the opposite direction, 180 degrees opposite, then her displacement from start to finish is just the size of the red arrow. So it's 4 minus 3 because it's in the opposite direction, which is equal to 1 kilometer to the right. So that's your answer. But I don't always have to turn 180 degrees around. I could just make a turn for 90 degrees. So here's 4 kilometers to the right, and then going down another 3 kilometers, and my resultant from start to finish is this red arrow with the double arrow there. That's how you do the resultant. And here we use Pythagoras theorem, which is 4 squared plus 3 squared square root, and you get 5 kilometers. Okay, so where do we use this concept of addition of vectors? We use this concept of addition of vectors for things like a boat that's moving down a river, or for an aircraft that's flying where there's a wind, a crosswind, a tailwind, or a headwind, or a crosswind. We'll come to the aircraft in a little bit, but here this diagram just shows you these are the two banks of the river, okay, the green ones, and the blue is the water in the river. So here's a boat that wants to go straight across, and the water is still, it's not flowing anywhere. So that's the speed of the boat, and people want to go from one bank to the other, they'll go. But suppose there was a boat parked parallel to the bank and it wasn't moored or tied to anything. This is what will happen. It's going to, and the water was flowing, this is what's going to happen. So if the water is flowing and the boat is not tied, the boat will just move along with the speed of the water. Okay, now suppose you have a river and the water in the river is flowing, and you want to go from this point here and you want to reach there, and you point the boat straight across and you go straight across. But this is what's going to happen. You're going to reach somewhere else, not exactly where you wanted. But if the pilot was smart, this is what the pilot would do. He'd point the boat into the stream, into the direction in which the water is going. So the boat is pointing that way, and then you reach the other end. So just to put it all as a diagram, so this is how we draw these relative velocity diagrams. So you have, this is the velocity of the stream or the river, okay, and this is the velocity in which the boat was going. So we say that's the velocity of the boat with respect to the river, okay, and that's the speed of the water. For somebody standing in the bank, that's the only person who's going to see the boat going this way. So this is your resultant velocity. So that's the velocity of the boat with respect to the bank. Or this is also called the true velocity in your booklets. Now this is when you point the boat into the current. So here's your velocity of the river with respect to the bank. That's the velocity of the boat with respect to the river. And this is your velocity of the boat with respect to the bank. We say with respect to the bank because the bank doesn't move. It's only the water and the boat that's moving. Okay, so suppose I put some numbers to this. So if the boat was going straight ahead, that's the speed of the boat. If the water is not moving, if it's going at 10 meters per second, it's still going at 10 meters per second. The second one, if the speed of the stream is 2 meters per second, the speed of the boat is 10 meters per second. The blue arrow, double blue arrow, is my relative or resultant velocity. And that you get square root of 10 squared plus 2 squared. So which is square root of 104, you get 10.2 meters per second. Okay, so but that you don't reach your destination, you reach away from your destination. And this is the one with the smart pilot, where you point the boat into the water, into this current. So the boat is pointed that way, but it ends up going straight. So if you need to know the size of that, it's 10 squared minus 2 squared. So which is square root of 96, and you get 9.8 meters per second. Okay, right, that's all for this lesson. So